Hi everyone, this is GOL from Productions², and I'm back for the next segment of our Space Crusade developers vlog. What is this? Anti-strophic filtering was set to time 16. Oh, okay. Don't need that because that was for the benchmark. Just trying to tidy up a few things here. Ah, crap, now I gotta I found out an interesting bug with Windows Media Player and this keyboard. That is, since the keyboard forces Windows Media Player to open, if you play a file and then try to delete the file after you close, Windows Media Player, it'll actually leave the file loaded because the process will remain open, and you won't be able to do anything with the file because it'll be still locked by Windows Media Player. So you have to kill the process manually in order to do anything with the file. Anti-strophic filtering was set to times. Again, now I gotta do the same thing. Just trying to tidy up desktop a bit here. Let's see, we'll take the rest of this stuff, throw it into desktop files. I think there's only one of those out here that goes to UOP. Where is my shortcut for it? Oh, there it is. Okay. That can go to desktop files. Go ahead and empty. Yes. Encoded files. Strange. I'm going to delete that. Okay. Well, it's a little bit cleaner looking now. To recycling bin, yes. Actually, I can throw this there. And anti-strophic. Just trying to get rid of stuff I don't need anymore that I didn't use for that there. Okay, I think that's all those files. Okay, so in the last segment we kind of went over the basics of C++, some of the more intermediate stuff as well. Today we're going to go more into some more of the technical kind of aspects of the language. Again, this is just to give you kind of a beginner's anti-strophic, or not really beginners, but just kind of a little background in programming so you understand some of the things you'll be seeing when we actually do the in-depth into Space Crusade. Alright, I think that does it. Alright, let's go and get Visual Studio open. We'll go back to that Hello World project we had from earlier. I'm also going to open up the that RPG game I had mentioned before. Actually, I'll have to go find it because I don't have it in the project list there. Let's see. G5. Code. Programs and games. Projects. I think this is it here. Probably have to convert it to 10, yeah. No backup. Next. Finish. Alright, so this is a RPG game that's based off of one from my Game Institute module C++ Programming Module 1 class. I guess you could call it a class. It's given in that book, and what I did was I took it and then I also went over it, recoded it from the book myself to kind of get a more hands-on approach at creating it, and then once I had done that, I went through and started adding things to it. So this is going to be the end result. The things that I added were skills, spells, I guess the map and the items as well. Everything else was already in the all these other files were already part of it. I might have added things to these though. For example, here you can see an instance of a constructor that you would use to create an instance of a monster. In other words, you would add the name, the HP, max HP, all the stats, and then that would create a monster that you could access with those attributes, and then you could go through and create another monster. That'd be a different monster class with a different name that would have different stats that you can access as well at the same time. Let's see. So here's the game .cpp file. Normally I would name this as main, but since since this was already there, I just left it as game. You can see there's the int main. And you have the random seed, the game loop here. Let's see, map. Then you have the map. I guess the map was already part of this as well. And you've essentially got 4 different enemies that you can fight in this small program, depending on a random roll. And essentially what happens is that you're creating a new instance of this class. We're just calling it monster though in this case. So monster, new monster, goblin. Or orc. Or orc lord or ogre. And then that goes back out to game where we go through the battle loop here. And then, while it's going through that loop, if the monster dies, all this code, or all these functions are called. If the monster isn't dead, you run this one. But if the player ends up dead, you run this code here, and then done equals true to end the game loop. But then once the monster is dead, you delete the monster. Or rather, once the battle loop is broken, you delete the monster from memory. Since essentially what you're doing is creating on the, if you look back over here, you're essentially creating a new monster to dynamic memory. So you have to delete the monster or else it stays in memory, which could cause memory leaks and other issues. And by doing this, you can actually access this new monster object that you've created from anywhere in the program without having to make a reference to it. I believe, anyway. I'd have to look at the original code to find that out. Let's see if I find the book. Here we go. Module 1, let's see, 5, section 5. Let's see, the full-on code definitions here. Map class. So yeah, the monster I guess it is, where is it? Up here somewhere. There's a monster. I must have removed it, but in the original code, after the SYN selection, right here, there's a line of code that defines monster as a pointer. So it's actually monster equals 0. And that loads that monster definition. But it also means that anywhere in the program that you now change monster, that change will propagate due to the fact that it's a pointer instead of a reference. A reference is a, well, shall we say, a temporary, I guess you could call it, direction to a specific class, whereas a pointer is a indefinite reference to a class, if you will. Pointer is loaded into the memory and can be altered from the memory to create a dynamic effect, if you will. I guess the best way to look at it is that a reference is a static direction to a class, whereas a pointer is a dynamic reference to a class or to an object. For example, arrays use pointers to function, essentially. And we'll get into arrays and matrices in a little bit here. Put that down there for now. Might need that later. Player. I also removed that one, didn't I? Huh. There's also a player reference here as well. So I kind of fixed up those issues. Then we have this supposedly has more, let's see, than monster. I'm supposed to send that there, so. And then we fixed up all of the issues there. And monster. Now I guess we do pass the pointer through then. Return 0. That's because it's a void though. Why is there a return 0? Say, I gotta check this again. So I made a lot of changes to this, and not a lot of them. Some of them may have made sense back when I made them, but they probably won't now. So know more about programming than I did back then. So that's kind of more of a hunt and peck, change things as I will kind of method to figure out what's going on. You could say a chaotic method of learning, cause problems, then fix those problems to figure out what I did wrong. I think that's probably the best way to describe what my process for that. Let's see, we're going to go further back. Monster class, we want the map class. Player class. All that's just about the player class, map class, here we go. Done. So actually it's a monster. Interesting. Its type is a monster pointer. That's very interesting. So, what I mean by that is that, if we go to map H, this is supposed to be, I don't think it's supposed to pass this. Well, let's see. Actually there's no, that's interesting, there's actually no, nothing being passed in the original. But in the original code it's actually done as a monster, this type of a class type. It's a pointer. With nothing being passed to it. Return encounter. I don't think that's in the original one either. Return monster. What's the original one? I guess that makes a little more sense then as to how that actually works. So, you could probably do the same thing with references as you do here. So ignore what I mentioned earlier, said earlier about pointers being loaded in memory and all that other BS. So that's not actually what the code was supposed to do. So essentially you're passing so essentially what's happening is that you have the monster class here, the pointer created. So maybe that is floated into dynamic memory because you're not actually passing anything to the map class to do anything with that. So I guess it is somewhat loaded into memory. But you're returning monster as that pointer, so you are in some ways directing that whatever is returned from here is going to be part of that pointer, monster pointer that we defined earlier. So I guess there is some level of dynamic memory being loaded. Again, that's why I have to delete it, because if you don't delete dynamic memory, it sits there forever and can cause memory leaks, as I mentioned earlier. But the other thing I added was items, or maybe items were already there from before. I know weapons were. And I also had spells and skills, though. Well, I didn't add skills in yet, but I did spells. And that's actually used, spells used in the player class as a member type. So I mentioned yesterday, or rather last night, or technically earlier this morning, since it was after 12, that they could be used as such. And here's actually two examples of that, where you have weapon being used as a member type and spell being used as well. And essentially what happens is, if we go over to player.cpp, you can see what happens here. So you have weapon, the weapon.m name. If you go back to weapon.h, you can see that there are two members for weapon. That is name and damage range. And again, range is being used as a member class here. So if we go to range.h, you'll see there's two members here, which is m low and m high. and that's to store the damage, low damage and high damage ranges for that weapon. And so when you initialize the player character, you need to set all that stuff up. So you have the default weapon name, the damage range low set to 0 and the high set to 0. For spells, same thing. You have the spell 1 and 2 names, the damage ranges, and the elements for both. And those are going to be part of the spell struct as well. String, element, damage range, mana cost. And this is how I originally had it set up for Space Crusade. If I go back to Planet Bomber here, you'll see that everything had a struct with all these different values and stuff. And we had all these, and those went over to here to these structs, and so on and so forth. And all the information was put in hard-coded into the code. Well, I decided to do a different thing with the current version of Space Crusade, and I'll show you that right now. And that was to use a matrix. But first, in order to understand what a matrix is, you need to understand what an array is. So actually, we'll leave that off for a second, so you don't get overly confused here. Let's go back to the where are you? Hello World program. So we'll make a new project here. We'll call it arrays, and console application. Console empty project finish, and here we are. We'll set it to the startup project, and we'll add the main file here. And we'll just use the main, we won't use a header or anything. So include IO stream, include string using namespace std. So int main. Alright, so I got the basic structure set up there. So now we're going to create a string array and an int array, and we're going to use those for this example. So string array. Essentially, an array is a grouping of elements that contain information. You can think of an element as a variable, except that it has a specific way of being accessed. There's no word type of variable name attached to it. It's just referred to as a number, and you'll see what I mean later on. But we're going to create a string array, which is an array that contains strings. You can also create a string that holds classes. I'll show you that a little later on as well. But in this case, we're going to say string, and then to define an array, you use a name for the array, so we're just going to say string array, and then you use brackets to indicate the number of elements in that array. So we're going to say 10. Now this is kind of backwards, if you will. There are actually the actual numeration of the elements in the array isn't 1 to 10. It's 0 to 9. All arrays and matrices start on 0 for the really all containers like arrays, vectors, lists, arrays, matrices, or matrices, however you want to pronounce it. All start from 0 and go to 1 minus whatever the set number of elements is. You can also either just define the array like this and set up the elements later on, or you can set the elements right then and there. So we're going to set the elements here. We'll say we'll just use it as test. Well, maybe not. Let's see. Actually, no. We'll use game names. I'll use some of the statistics from my benchmarking video for this. Battlefield 3, Call of Duty Modern Warfare 3. You can also do this lengthwise, where you have this all going horizontally instead of vertically, but vertically just looks better, in my opinion. It's more organized. Symphonia, Dawn of the New World. Let's see, so that's 1, 2, 3, 4, 5, 6, 7. Zone of Enders. Metro 2033. 1, 2, 3, 4, 5, 6, 7, 8, 9. Need one more. So we're gonna have one extra that I didn't actually do, just because we need to. Well, actually, no. Let's just leave it at. Let's leave it at 9 and switch this down to 9. Alright, so there's our string array, and it's been identified, or defined rather. And then we'll do an int array for FPS values, or average FPS values, I guess we'll say. Actually, no, we'll do a float array, and essentially what a float is a integer value that can have decimals in it. So where is my listing of the various FPS values? So I'm going to need that. Actually, this isn't. Never mind. Here we go. Okay. I'm going to use the old benchmark average values for this. So, float. Let's change this to game names. And so floats FPS average values. Get the friggin' correct characters here. And again, 9 equals. And this one I'll do the lengthwise definition. And for characters, and because you can do character arrays as well. But for whenever you're putting these in, you have to stick to the conventions of how they're defined. Strings use quotations. Characters use the parenthesis. And integers and floats. Well, floats have an F at the end of them, but don't have any symbols used in them besides the period decimal point for the decimals. But and integers don't use anything as well. So, and also when you're doing something where two arrays are going to be listed in the same order. In other words, the first element of one array is going to be compared to the first element of another array. You need to make sure that the arrays are arranged correctly. So in other words, if I put Call of Duty Modern Warfare 3's FPS value here as the first element, it's not going to read correctly because it'll read as Battlefield 3's first element. Unless you want to go through and manually set up the set up the comparisons and the counts by hand by saying, game names 1 or game names 0 and FPS A values 1. In order to do, if Battlefield 3 was the second, Battlefield 3's FPS value was the second one in this values array. But it's much easier just to do them at the same time, or do them in the same way. So for Battlefield, we had a 92.46 frames per second average. For let's see, so 184.90. Uh, 47.90 Crisis. 8 59.76. 59.72. Dark Spore. Let's see, 58.51 for toss. 59.12 for toss 2. Some of the unders 56.78, and Metro 2033 was 70.54. And there's the other way you can do the defines for arrays. Forgot all the F's on these. Drop some F's into place. Alright, so now that we have the arrays defined, let's see, float array. We can go about actually using these arrays. So what we're going to do is actually use a for loop. And a for loop is like a while loop, except for in a for loop you are looping through the loop for a certain number of times. And that's usually defined by using the value that you're wanting to, that contains the number of times you want to go through the for loop, compared to another variable such as I. I use I for my for loops because it stands for iteration, and so an iteration is just a fancy coding term for meaning X time through. So for example, I iterated through Mass Effect 2 12 times. That would translate into something that would be understandable as I played through Mass Effect 2 12 times. That's just what it means. So we go for. Now, for a for loop, you have three different attributes, if you will, to define. The first one is the value that is going to be used as the initial starting point. The second value is the conditional statement that determines when the for loop will end, and the third statement is if you want to, how you want to increment or de-increment, if you want to de-increment or increment the value. So, for example, we'd use int I equals 0. So as long as I is less than size of g names. Now, this size of function will look at the array that is defined, in this case game names, and it will see what size the array is in terms of how many elements, and it will use that value. Now, one thing to remember though is that it's going to use 9 for that value, and the array starts at 0 and only goes to 8. So if you have 9, it's not the I is going to go until it's as long as it's less than 9, but it will still hit 9, and when it does that, it will cause an error. So you want to say -1, so that it only goes to 8. And then the second one, we're going to increment the I value 1 time each time it goes through. You can also do a --- to de-increment that value. So if you start at a higher value, like if we say, if we want to, we could start at 8, and then we could say as long as I is greater than 0, or greater than, as long as I is less than or equal to 0, let's say. You can continue through it that way. And then it would go through each iteration and take 1 off of I, which would mean that it would de-increment down to 0, and then once it reached -1, it would end. We're just going to go the standard way that I had it before, where we increment through. And what we're going to do here is, at the beginning we're going to do a count. We're going to say game benchmarks. And now what we're going to do is that we're going to, when we iterate through each time, we're going to print out the particular contents of the element that the array is on. And how we do that is by using the array name. So in this case it would be game names. Well, we do count first, obviously. Then we go game names. Then we use the brackets and we put I there. And so for this, what's going to happen is that whatever value I equals is going to be used to find that value of elements, that element in the array. So on the first time through, I will equal 0. So it's going to print out element 0 of the game names array. And then we'll do a thing here. We'll say let's see. And then let's do a space. We'll do a space. Oh no, we'll do a separation thing there, and then do FPS a values, and also do that with I, and then do the endl. And essentially, that's all we need to do. What will happen now is that this will iterate through and print out all these values and strings if nothing goes wrong here. So let's go ahead and build it and see what happens. So as you can see, we had access violation error. And the reason that happened is probably because, well, actually I don't know why. Let's see. Go back to main. Let's go ahead and actually close this main. That's interesting. crt.exe. Get main args. This is very interesting. Actually, never had that particular error happen before. Let's go to. Oh, we had it set to debugging now, didn't we? Debug, stop debugging. Let's just build it. Or rebuild it, rather. Let's see. No failures, so there's no errors. Creating, let's build. No warnings either. So let's open it up in the, right, go back out here, go to release and erase. Okay, so yeah. One, two, three, four, five, six, seven, eight, nine. 1, 2, 3, 4, 5, 6, 7, 8, 9. So something's not working correctly here. Well, I is less than -1, which is 8. Let's go less than or equal to. Although it shouldn't matter. No, it's still going wacko. Huh. This is very odd. I'm sure there's probably some programmer out there watching this video thinking, oh, you idiot, this is the reason why it's doing that. But, at the moment, I am pretty much lost as for why that's happening. 9, 9, this all checks out. It's 0. Plus I, plus, int main. Oops, I want main. Maybe I see main int, see int main, get ch. Well, for one, I did forget to do that, get ch, but I don't think that's what's causing this, though. Underscore get ch. So, cout, get names I, done, FPS A values I and L. That's all correct. Benchmarks, float array. Maybe this is it. Let's see. No, that's the way it should be. Or maybe not. I do have it set with another one on that one, but that might not be necessary. I got one there too. Well, let's see what happens then. We add a extra comma on the end of this here. Nope. Still doing it. Debug, stop debugging. I'm not sure what the hell's going on with that. That's kind of strange. I've never actually had that happen before. Huh. Very odd. crt.exe.c. Let's go do a little searching here. crtexe.c. Let's see. Stack Overflow. What's the error then? So is there a 5? Is that what it said here? No, different one there. Oh wait, no, we want the exception name. First chance exception, unhandled exception. So, unhandled exception. So I don't know why it's doing that. Take a look at the code here. Maybe I'll figure it out. String names equals 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9 string. Use namespace std, string is string, float array. Maybe it's the float array. Let's change this to an int array instead of a float. Never actually worked with a float array before, so maybe that's not how they're defined. Still got a problem. Odd. Int main string array. So this is where you get to see some fun debugging of weird problems. So that's not the issue then. So the issue's got to be something in here. Okay, let's go ahead and go ahead and minimize this so I can see this at the same time here while we're running it. Okay, F5. So it's only when we get to the end that it goes batshit crazy. Maybe it is the -1, although I don't think it is. Doesn't make sense for it to be that. Stop debugging. Let's go -1. Take out the equals. Yes, rebuild it. Nope, still goes crazy. Question is why? So let's go the other way. Let's go -2. Nope, still crashes. Set exception at. Let's see, +C++. Nothing found for that. Maybe there's a list of unhandled exceptions here on Wikipedia. That looks familiar. 774F15DE. 7, nope, it's not the same. Well, when all else fails, turn to a forum somewhere. I'm not gonna keep recording until I get a response, though, but let's go ahead and copy this. So, title. In case you're wondering what AVE stands for, it's Access Violation Error. File entry point. Plus empty user project. Standards compliant browser. Just reading through this stuff, see if there's anything relevant here. I don't think there's anyone. Let's see. I have a And actually, since I know that float wasn't the issue, I'll add that back in as well. Preview. Insert. However, when I run this program after the final see. Need the actual error code here. No, not the exception. Let's try using the, that code. Here we go, there's some more about this now. Let's read about it here, see what's going on. App tweaked bug, 1000, machines, blah blah blah. Wow, that's from friggin' 2003, or 4. That's old as hell. Let's see, Microsoft Reader. That's not what we're looking for. Violation error in exe. Trying to design thread pool after job, blah blah blah. Exception, it stopped here. And again, stuff that's more complex than my program. My program shouldn't be causing that to happen. It's too simplistic. Let's see what is brought up with that. Anyway, let's try just making a more simple thing here. Let's go ahead and kill off that last bit. See if it still errors out. Yep. Sure does. But you kind of see how that works from that. Even though it turns into a flaming ball.